content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. In this episode, we break down the most common reasons solar panel installations fail electrical inspections, from grounding and bonding mistakes to labeling issues, first means of disconnecting problems, and poor workmanship. I will explain what inspectors are looking for and how installers can avoid costly re-inspections and delays. Whether you are an installer, electrician, contractor, or homeowner, this episode will help you understand the inspection requirements and pass the first time. Different states and local jurisdictions across the United States may adopt their own ordinance, standards, and regulations governing electrical installations, building codes, and safety protocols. However, the National Electrical Code, developed and published by the National Fire Protection Association, established a comprehensive, nationally recognized standard intended to promote uniformity and safety. All solar panel installations are required to comply with Article 690 of the National Electrical Code, adopted by the authority having jurisdiction, and must be installed in strict accordance with the approved set of plans, regardless of state or local variations. The National Electrical Code serves as a uniform guideline that defines detailed requirements for conductor sizing, grounding and bonding, overcurrent protection, wiring methods, and installation ratings. The purpose of the National Electrical Code is to ensure electrical safety, system integrity, and consistent applications of code requirements across all electrical installations throughout the United States. In this episode, I will explain in detail why solar installation so frequently fail inspections and what factors contribute to these issues. Solar panel inspections are a critical part of the installation process, serving as a vital quality control step to ensure safety, code compliance, and system reliability. These inspections are not just a formality. Improper conduct can result in significant delays, costly rework, and financial setbacks for installers and clients. Many failures are caused not by faulty or substandard equipment, but by overlooking small but critical code violations, such as improper grounding, missing labels, or insufficient clearance from electrical panels. It is essential to recognize that inspectors are not anti-solar actors. Rather than their role is to enforce strict safety regulations derived from the national and local electrical codes. Most solar inspections fail because the installer or contractor has overlooked key details, such as correct conduit support, proper labeling, or appropriate wire gauge. This disconnect often stems from a common mindset. Installers tend to focus on optimizing systems, performance, and aesthetics, while inspectors emphasize on adherence to safety standards that prevent fire hazards, electrical shocks, and structural risks. Understanding this dynamic can help installers better prepare for inspections by thoroughly reviewing code requirements and conducting detailed pre-inspections. By paying close attention to these critical safety and compliance aspects, the likelihood of passing inspections on the first attempt increases significantly. Let's get started. In recent years, Out-of-state solar companies have increasingly conducted installations under the misconception that differences in authority regulations across states or local jurisdictions allow for alternative interpretations of the National Electrical Code, safety standards, or installation procedure. This situation aims to assist both local electrical contractors and out-of-state solar companies in reducing repetitive mistakes and successfully passing solar inspections. While enforcement's practice may vary, adherence to the electrical code is consistently required. To address this misunderstanding, I have compiled a list of the most common reasons these projects often fail electrical inspections. The list begins with inconsistent adoptions of code cycles. Assuming that a jurisdiction enforces the same National Electrical Code edition as other states or authority-having jurisdictions, often result in non-compliant installations. Installers must verify the adopted code cycle and any local amendments before design and installation begins. As an example, 2014 code, 2017 code. You must make sure that you know what code cycle your authority having jurisdiction is on. Although my jurisdiction is currently enforcing the 2014 National Electrical Code, an electrical contractor may submit drawings and specifications based on a newer code cycle. However, the National Electrical Code edition selected at the time of submittal becomes the governing code for the project and will be used throughout the inspection process. Interchanging requirements from different NEC editions is not permitted. Next thing, lack of coordination with the authority having jurisdiction. Failure to coordinate with the authority having jurisdiction early on in a solar project, especially when unique site conditions or alternative methods are involved, often result in avoidable corrections and failed inspections. Early communication and pre-installation clarifications can eliminate many of these issues before work even begins. Why these inspections fail before we even get started. One of the most common problems I encounter is that the solar installation is already fully completed before any inspections occur. When this happens, the project is set up for failure from the start, right out of the gate. The inspection will fail if the solar job is already installed prior to an inspection. Key contributing factors include the lack of coordination between the electrical contractor and the AHJ electrical inspector. No rough cover inspection scheduled prior to the solar panel installation. Installing solar panels before the required rough cover inspection will result in an immediate failure. Here are the required inspections to get you started out on the right foot. At least every solar installation must include 2 inspections: the rough cover inspection and the final inspection. If the electrical contractors skipping or avoiding any of these inspections, I can guarantee you there will be corrective actions. The rough cover inspections. During the rough cover inspection, the inspector will meet the contractor on site before the solar panels are installed. The inspector must verify the following: the plans, permits, and listing of the solar panels. A stamped approved set of plans must be on site. The municipality building permit must be posted and visible. All installed equipment, material, and solar components must match the approved set of plans. An example that was recently found: plans specify that a solar panel REC 400 AA, but the installed panels were REC 395 AA. The inspection failed. All panels and equipment must be listed and verifiable. If the inspector cannot see it, we will not approve it. Next thing on the list, site access. A ladder must be available on site to provide for a roof access, preferably presented during the rough cover part of the inspection. May be allowed at the final if a responsible party is present to answer questions and set the ladder up. The final inspection. The final inspection includes a full review of the completed installation against the approved set of plans. The inspector will verify the overall to make sure that the overall NEC requirements are in compliance, proper installation of all equipment, and conformance with approved set of plans and listings. Failure to follow manufacturer's instructions. The electrical code compliance requires strict adherence to the manufacturer installation instructions. Deviating from listed installation methods for solar PV modules, energy storage systems, batteries, inverters, racking and mounting systems, disconnected means, monitoring equipment, or associated components is a common cause of inspection failure and cannot be justified by approval, practices, or interpretations except in any other jurisdiction. Failure to follow manufacturer's instruction constitute products misuse and may shift liability from the manufacturer to the installer or the end user if such negligence contributes to injury, property damage, or the system failure. Proper compliance with the manuals, listing, and safety warnings is essential to prevent hazards such as electrical shock, fire, or mechanical failure, including equipment detachment or collapse. Inspectors frequently cite Article 110.3b for things such as installing equipment that does not adhere to the manufacturer's instructions, things such as using mounting hardware or fasteners not specified in the manufacturer's manual, things that are not conducive to the environment. Consideration must be given to the weather elements versus aluminum versus stainless steel. Also, things such as conductor bending radius, the torque value, or the environmental ratings. Also, pay attention to improper bonding and grounding methods that differ from the listed instructions. Mixing components from different manufacturers will not be allowed, even if the installer or the electrician says things such as it passed somewhere else. We've always done it this way. Other authority having jurisdiction allows it. None of those excuses will override Article 110.3b. Another thing that's tied to Article 110.3b is the liability implications. Once an installer violates the manufacturer's instructions, the product is considered misused. The manufacturer's liability is often voided. Responsibility shifts to the installer, the contractor, or the employer. Injuries or failures may trigger civil liabilities, OSHA citations, or insurance denials. From an enforcement standpoint, the inspector does not have to prove intent only that the installation does not match the listing instructions. Now, I will give reasons why these type of installations fail electrical inspections. The electrical PV inspection corrections, service and feeder requirements. A detached structure, disconnect, missing. A disconnect means it's required for all feeder conductors supplying a detached structure. Article 225.31a. 200 amp disconnects installed on an electrode conductors must be sized for a 400 amp service. So this one was undersized grounding electrode. Article 250.66. Main water bonding location incorrect. The water grounding conductor must terminate at the first means of disconnect. National Electrical Code, Article 250.24a. Incorrect use of SCR cable. A 3-wire is installed to feed a subpanel. A SCR cable is required. It's permitted from the utility meter to the combiner panel. 4-wire SCR cable required from the combiner to the interior subpanel. National Electrical Code 380.10b4a and Article 334. Next on the list, panel boards and overcurrent devices. Swear D breakers installed in Eaton panel. Breakers not listed or approved for this panel. Equipment must be installed per manufacturer's instructions. Article 110.3b. Incorrect breaker size installed. Replace 40 amp breaker with approved 30 amp breaker. Approved plans. Electrical Code 110.3b. Next on the list, grounds and neutrals not isolated in the subpanel. Grounds and neutral must be separated in the subpanel. National Electrical Code 408.40, also 250.142b. Next on the list, bonding screws installed in subpanels. The bonding screw must be removed per Article 250.28. Next on the list, subpanel cabinet not bonded. The cabinet must be bonded to equipment grounding conductor and systems. Article 408.40. PV systems requirements. The PV-DC arc fault protection is missing as required on the plans. Must be protected by a listed arc fault device. If it's on the plans, you must follow the plans. National Electrical Code 690.11. Next on the list, PV equipment located on the stairs. Overcurrent devices and disconnects are not permitted on stairs. Article 240.24f. Next up, solar panels do not match the approved plans. As mentioned earlier, they must match, so the approved plans specify REC 400AA and the installers had on site REC 395AA. Must match the approved documents. Next up is disconnect type does not match approved plans. Disconnect type does not match approved plans. Plans call for non-fuse disconnect. What was installed was fuse disconnects. Next on the list, the bottom rails on the roof not bonded. All metallic PVC racking components must be bonded. Article 390.43. Next up, we have raceways and conduit and fittings. Unlisted transition fittings installed. The fittings must be listed for the wiring method used. You cannot make a go-to fitting. It has to be an approved fitting. So therefore, you cannot take a heavy wall coupling and compose what we call in the field a go-to connector. It must be a listed connector, Article 300.15. Next up is a compression connector installed at the top of the disconnect over overcurrent live energized parts. Myers hub is rain tight, is required where entering above live parts. In Electrical Code 3, Article 312.2, and also look at Article 110.11. Next on the list is rigid nipples, missing rain tight lock nuts on the exterior. Lock nuts required on the exterior of enclosures. National Electrical Code, Article 300.12. Metal raceways terminate in a plastic box without grounding. Metal raceways must provide an effective grounding path. National Electrical Code, Article 250.86. Next up is FMC raceway installed in a wet or damp location. Flexible metallic conduit is not permitted in wet or damp locations. Article 348.12.1. Next up, underground PV raceways missing expansion fittings. Expansion fittings are required to accommodate earth movement. So if you're going underground with power, expansion fittings are required. Article 352.44b. Next up, EMT within 3 feet of a disconnect not supported. So the EMT must be securely fastened in place. Article 358.30. Next up, EMT exterior not plumb or level, so that this installation must be neat and in a workmanlike manner. National Electrical Code 110.12. The next thing on the list is the conductors and protection. Missing bushes on number 4 or larger conductors. Installated bushings are required to protect conductors. Also, if you're emerging from underground, you must use a bushing on the underground raceway. Low voltage cable entering panel without a bushing, and burrs are present. Conductors not protected. National Electrical Code 300.4. Also check out 110.12. Next up, we have clearance and labeling and signage. Electrical equipment missing required labeling and signage. The panels must be labeled, including in the garage. National Electrical Code, Article 690.4b. Next up, PV service panel lacking required working space and illuminations. The equipment must meet working space and environmental requirements. Article 110.26 and requires illuminations for servicing purposes. Final notes. The installation does not match the approved set of plans. All work must be installed per approved plans and specifications. Any deviations require resubmittal and approval prior to inspection. The deficiencies noted above are common, preventable issues observed during solar panel installations. These items must be corrected to comply with the adopted National Electrical Code, approved plans, and manufacturer installation instructions. Failure to address these violations may result in reinspection fees, project delays, or additional enforcement actions. The intent of this inspection is not to impede the project's completion, but to ensure life safety code compliances and system integrity. When installations are properly planned, coordinated with the authority having jurisdiction, and installed in accordance with approved drawings and listed equipment instructions, inspections are typically straightforward and routine. All corrections shall be completed prior to re-inspections. Contact the authority having jurisdiction if clarification is required before rescheduling an inspection. Inspectors are not here to stop projects. We are partners in ensuring safety, code compliance, and long-term system integrity. When work is planned and executed correctly from the start, the inspections are efficient and routine. Join me on Wednesday, February the 25th, for another informative episode where we will review the necessary safety procedures outlined in the National Electrical Code. We will discuss common pitfalls to avoid and provide practical tips on how to prevent errors during electrical inspections, ensuring safe compliance and reliable electrical setups. If you are looking to expand your knowledge of the electrical code standards, code compliances, and best practices, consider checking out 60 Best Electrical Podcasts available at podcast.feedspot. This resource is valuable for anyone aiming to stay informed, improve their skills, and deepen their knowledge of electrical work and safety. Feel free to reach out through social media with any questions, comments, or topic ideas. You can find me on Facebook, Instagram, and YouTube under the name Ask the Lady Electrical Inspector. Also, you can email me directly at asktheladyelectricalinspector@gmail.com for more in-depth discussions, feedback, or to share your specific electrical concerns. Together, we can keep our electrical system safe, reliable, and up to code. Your involvement and dedications are vital to making our community safer for everyone. Thank you for tuning in. Until next time, stay compliant, stay safe, and keep the power flowing. Good night.